Well, hello and welcome to another Corporate Facilities Group informational video. I am Paul Housleben and I am the Vice President of Operations for Corporate Facilities Group. We're based in Atlanta, Georgia, and we are a leading provider of facility management, property management, and maintenance services, as well as technical consulting. And today, we'd like to walk you through some basic chiller plant operations of a fairly large office building. We cover the nation, even though we're based in Atlanta, Georgia. I am in Virginia today at a building that was renovated about 4 years ago from single tenant use to multi-tenant. And during that renovation period, we also totally rebuilt and updated the chiller plant. This is just basic information on how a chiller plant operates. This, of course, is the cooling systems for the building. And this is an office building, so this is comfort cooling. We have a small data center operation here, but it's handled by independent little package units. Not a large data center operation. Sorry for all the noise here, but chiller plants tend to be quite noisy. So we'll run you through real quick here, basic chiller plant operation. And this building is about a little over 100,000 square foot. We'll call it 310,000 square foot. So we have two 400-ton chillers that I'm looking at right now. These were updated. The original chillers used old-fashioned refrigerant, R11 refrigerant, and they were removed in a renovation and replaced with these high-tech Daikin McQuay chillers. If you look closely on the top of the chiller there, and I will do my best to kind of zoom in here a little bit, and you will see that these have high-tech motors on the top that actually use no oil. These motors run in a suspended animation, so they have no real friction, and they save you a ton of money on electrical over the old-fashioned chillers. Both of these chillers are not running. It's a very cold morning here. I'm going to walk over to this one, and you can see it has a really nice screen on there that gives you some eye candy of pretty much what's happening with the machine as far as pressures go and temperatures. Here you can see the little motor nomenclature on top. But we're going to look at the chiller and tell you how it works. Now, basic physics and refrigeration principles come into effect. If you buy a carton of milk at the grocery store and you put it in your refrigerator, the refrigerator actually removes the heat from that milk, and therefore it makes it cold. Basic physics with hot and cold principles. So a chiller works on the same principle. It makes cold water, which is circulated through the building, attracts the heat, picks the heat back up, and removes the heat through what we call a condensing loop. So we have two sides of the chiller. We have the chill water side, which has the insulation on it, and we have the condensing side, which is non-insulated because it's warm. And pretty much what we do is we make cold water with the compressors and the refrigerant. You can see the chill water pipes. We'll follow them. And they come across the top of the chiller plant, and they go to a series of pumps. These pumps pump the chill water up and down through the building to a series of air handler coils staged throughout the facility, and that has a fan behind it which blows the cool air into distribution boxes in the office space. And that's an oversimplification, but that's pretty much how it works. Now, as the heat is picked up in the loop and it comes back to the chiller machine, the heat is then put into the condensing side and rejected out through a system called a cooling tower. And we'll take a look at the cooling tower. Now this is a waterside condensing chiller plant, and they require a lot of maintenance. As you can see, this one is pretty much kept immaculate. Guys do a great job here, but you do have to attend to your chiller plant pretty much 3 or 4 times a day. So here comes the warm water in the condensing loop. It goes to these pumps, and then it leads to outside, where there's a cooling tower sitting on the outside. And the cooling tower is a large reservoir, and it has fans at the top of it, and the fans reject the heat into the atmosphere. We'll take a walk out there. It's kind of dark and cold today, but we'll do the best we can. This is a sump heater, and what this does is it keeps the basin of the cooling tower from freezing solid. It does get quite cool here in this part of Virginia. It gets awful hot and humid in the summer too. So there you have a heater. It's an electric heater which tries to prevent it from freezing solid. There's also heaters in the bottom of the sump of the cooling tower. Now this building also has a nice feature with what's called an economizer, and that's what we're looking at now, or a heat exchanger. And what this piece of equipment does, through some sophisticated automation, which is located in the building in the chief building engineer's office, it watches a condition called enthalpy. And when it decides that the outside temperatures and the water in the cooling tower has now become so cold that it can utilize that water for free cooling, it shuts the machines off, chiller machines, captures that water, circulates it through this machine, which is basically just a bunch of copper plates, and migrates the cold water from the outside to the warm building chilled water, which comes in there, and therefore through principles of physics, it takes the cold water and makes free chilled water, courtesy of nature. So that's a pretty cool operation. There's a series of valves up there. If this water gets too warm, what it does is it'll shut these valves off automatically, and then once more just turn your chiller back on to have the mechanical cooling. So pretty cool little system. Like I said, it gets cold here in Virginia, and if we have a good week or two of real cold temperatures, this water will stay cold for a long time, and the owner will reap a lot of benefits here, because this will save him a bundle of electricity in running these machines. Even though these machines are quite economical, you can imagine, you know what your electric bills are at home. If you run these machines for a long time, it's going to cost some money. When we did the retrofit here, we preferred to keep the old-fashioned pneumatic actuators, which are air valves, or air actuators that operate mechanical valves. They're very, very reliable. They've been here for years. Every couple of years, the crew here will replace the diaphragms or do a little maintenance repair on them, but for the most part, they are very trouble-free. Sometimes the electric valves can be a hassle. So we kept the pneumatics. There was nothing wrong with them, and saved a bundle of money on a retrofit to new valves. So with the air valves, we have to make air. So we have a large air compressor here, which makes air for the chiller plant. As you can see, that is an old air compressor, but it's once more kept in immaculate condition by this crew here. To keep the air nice and dry, an enemy in pneumatics is moisture, so we have an air dryer, which is basically a refrigeration unit that dries the air leaving the compressor. Also removes some oil. Because these are new chillers, they do use a new refrigerant, which is not a happy chemical, and it is toxic, as opposed to the R11 refrigerant, which was an ozone killer, but it was not deadly. So if we have a catastrophic failure here and a refrigerant leak, we do have a sophisticated detector here, which is constantly sampling the air for any issues. It will lock down this chiller plant so that no one can enter. And over here, it will turn an emergency fan on, which will evacuate the air up through and out to the atmosphere. It will also take in a bundle of fresh air through this system here, and of course replenish the bad stuff with fresh air. So let's see, it's going to be dark outside. We'll walk outside, see if we can take a look at the cooling tower here. Once more, sorry for all the noise here. This isn't even that bad because the chillers aren't running. I know, it's kind of dark here, but take my word for it. There's a big giant tower out here, and it's got a bunch of fans, and the water circulates around, and that's the way we get rid of the heat. So that's about it for now. See if I can get back into the chiller plant here without killing myself. Thanks for tuning in. We are Corporate Facilities Group, based in Atlanta, Georgia. You can find us on the web at www.corporatefacilitiesgroup.com. If you have any questions, you can email us here or give us a call. We'll be happy to chat with you about anything that might be happening with your building. So that's it from the chiller plant. Good luck out there with your own air conditioning systems. Thank you.